You mentioned the fact that some of these wild-type GISTs might be treated by this drug that's attached to the BRAF mutation. Have I got that right? In which case...
That's a theoretical possibility.
Right.
Do you know,
how would a clinician get hold of it?
Maybe I'm going to ask Steve, I've just seen him walk in. Steve, are there any trials using Vermufurup? I can never pronounce it. Yeah. It's a theoretical possibility.
Excuse me.
Yes.
Since I've worked with just Support International in the USA, and
Can you use the mic?
Sorry. USA patients can actually take liberties in the clinical process in some ways because they can actually ask for a drug. I do know of one patient in the USA who's got this mutation who is on the melanoma trial, and his tumour is actually responding for the first time ever. So it's actually in regression. This has never happened before with any other treatment for him. So the theory does work for this one patient, although I have to say it's only one.
One does have to be a little bit... the story of BRAF is quite interesting. So,
shall I introduce Dr. Steve Falk, who's one of my colleagues at the BRI, who's an oncologist.
Hi there, yeah. So, good morning everybody. So the story about BRAF is very interesting. So this is a molecular marker, but it's also an important potential target for anti-cancer treatments. And in melanoma, with a very specific mutation in BRAF, and there's a very specific mutation in BRAF, there's a drug that is very effective. Now we also see BRAF mutations in colorectal cancer as well, but the drug doesn't work in that disease. And actually what is an important message is you may express a target, it might not necessarily, however, be an activating mutation. In other words, giving a treatment to that mutation just because it's there doesn't matter. It's a bit like having a wheel. The wheel is either going round or it's not. So it can stop if it's going round, but it can't stop if it's not going. And it's an analogy like that. And in fact, we see c-KIT, which of course is the target of imatinib, that's overexpressed in a number of other sarcomas, but in reality, Gleevec doesn't necessarily work in other sarcomas, certainly not to the same extent. So just because that target is there, that target might not necessarily be doing anything, or as we'll see later, there may be ways that cells get around that target, and there are lots of other mechanisms as well.
Thanks, Steve. How do I decide who? The ladies first.
Thank you. There are some of us that don't have any of the BRAF or altered SDHB or IGFR expression, so are still in the completely undiagnosed wild-type group. And there is the facility now with genetic testing, by exome sequencing or whatever, to potentially look at that. Is there any plan for the wild-type GISTs that aren't sorted to have that sort of analysis done to try and get, because it could be a completely different gene or gene family?
With regards to next generation sequencing, I wouldn't be surprised if some of the wild-type clinics, see the guys in the States, they collect a larger number of patients than we would in the UK. And I know there is an ex-colleague in Ireland, Maureen O'Sullivan, who's collecting wild-type GISTs as well. So I don't know off the top of my head, but I wouldn't be surprised if they were going to be studying those cohorts of wild-type GISTs with next-generation sequencing.
What is next generation?
Sorry, I beg your pardon. Okay, next-generation sequencing is when I talked about sequencing, we were talking about a single exon of a single gene. With next-generation sequencing, you would study almost the whole genome, or certainly most of the genes in the genome, more or less at one time. So it gives you banks and banks of information. One has to be careful, though, with information, because just because something is mutated, as Steve said, doesn't mean it's driving the tumor. It may be a secondary phenomenon. So just because you found a mutation, doesn't necessarily mean targeting that mutation will affect the tumor growth. But it does point towards certain genes which may or may not be important in the development of that tumor. Sorry, just to call your chap next to him.
You mentioned that there are certain drugs which treat, or certain mutations which respond to certain drugs better. And on your table you had them down as the primary
Mutation. Yeah.
Why are you able to say why it is that when those drugs fail, other drugs then seem to work?
Okay, so where shall I start? A primary mutation is it's called the first mutation that a GIST will have. And that happens and is found when the GIST develops or is diagnosed for the first time. A secondary mutation, this is the theory, comes about when a patient's been treated with a tyrosine kinase inhibitor for a long period of time. And it's probably thought that that secondary mutation exists at a very low level in the tumour. But because that cell or two which contains that mutation can grow freely when imatinib is floating around, it is encouraged to grow out. So primary mutations are probably there as a secondary mutations, but the primary mutation is what you see to start off with. So a secondary mutation will occur in certain parts of the gene for KIT that, for example, imatinib will bind to, right? And therefore it blocks imatinib working on that cell. But sunitinib works in other ways as well. It doesn't just target KIT, it targets other pathways as well. And Steve mentioned that sometimes if you target one pathway, these unfortunately clever neoplastic cells will choose another pathway to activate the cell or the growth of the tumor with. But sunitinib targets other pathways as well. So that might be a reason why a drug like sunitinib might work with some cases where a GIST has a secondary imatinib-resistant mutation. Does that sort of answer your question?
Well, it does. But what's interesting for me is that I understood from what I thought had been told previously that your mutation doesn't change.
Your primary mutation shouldn't change. It
Right.
should stay in most of the GIST cells, including if you're unfortunate enough to have metastases. In all those metastases, what you will see, however, is what we call heterogeneity of variants in the secondary mutations which could develop, not only amongst different metastases, but even within the same metastasis. And that's probably because I said these secondary mutations probably exist at minute levels in the original tumor, but there's probably going to be more than one secondary mutation lurking in there. And so different ones will outgrow in different places, or even within the same place. So the primary mutation does not change, but you can get different secondary mutations at different sites, or even within the same site.
So, sorry to go on, but should then, each time the tumour is metastasized, should there be further mutation analysis done?
This is controversial because the problem is, let's just say I had a GIST and I had 3 liver metastases. Okay, let's just say one was biopsied and that showed, I don't know, an exon 13 secondary mutation. It doesn't mean that the other 2 will have the same mutation. And further, it doesn't mean that all of that biopsy metastasis will have that same mutation. So that's part of the reason why secondary mutation data is not used so much clinically. Those are limitations. It's that heterogeneity which is a problem. So at the moment, I think most people probably say no because of that reason. There's just too much heterogeneity. If you could biopsy the whole thing, which is resecting it, well, you've resected it anyway. So unfortunately not.
Did you have a question?
Oh yes, sorry.
It's the same.
Yes.
It's the same question.
subject.
Oh, was it?
So how do we get all patients to get a mutation analysis? What can we do to promote that?
What normally drives the nationwide sort of like testing of something is a guideline. That's a nationally accepted guideline, which will say something to the effect of thou shalt test all cases of GIST. Now, I'm not saying that will happen, or to a certain extent that should happen, because as Steve may talk about, with adjuvant therapy, it's particularly, for example, the high-risk GISTs which should be tested. But until a national guideline says what we as diagnosticians should do, it's unusual for it to happen, particularly because of funding. Unless a national guideline says it should be done, it's difficult for us as the laboratory to carry out the test to get funding. In fact, I can say with great confidence that all 6 labs basically do this analysis for free, effectively. There's no direct money that we get, but because GISTs are relatively rare, it's not so much of a problem.